In this video, I want to look at how to find the expected value of a continuous variable. Just like with discrete variables, expected value is denoted by e of x or by mu. And the expected value of a continuous variable is given by the integral from minus infinity to infinity of x f of x dx, where this f of x is our PDF. So let's look at some examples. For my first example, I have a PDF given by f of x is equal to 2x when x is between 0 and 1 and 0 otherwise. So to find my expected value, I need to look at the integral from 0 to 1, since that's where my actual function is defined. And then x times f of x, so we need x times 2 of x dx. So this is the integral from 0 to 1 of 2x squared dx. The integral of 2x squared is going to be 2/3 x cubed, going between 0 and 1. So we have 2/3 times 1 cubed minus 0 cubed, which is just 2/3. The expected value of this particular continuous variable is 2/3. Next, let's try to find the expected value of the uniform distribution from 0 to 1. So as a reminder, the PDF for the uniform distribution is equal to 1 when 0 is between, or for when x is between 0 and 1, and 0 otherwise. So in this case, we would need the integral from 0 to 1 of x times f of x, which is 1. So x times 1 dx. Well, the integral of x is 1/2 x squared between 0 and 1, and evaluating this is going to give me 1/2. So the expected value of the uniform distribution between 0 and 1 is 0.5. Next, let's let f of t be equal to 0.1 e to the negative 0.1 t for t greater than 0, and 0 otherwise. So this time for my expected value, I need the integral from, well, my function starts at 0 and goes on indefinitely, so the integral from 0 to infinity of t times 0.1 e to the negative 0.1 t dt. This is the integral from 0 to infinity of 0.1 t e to the negative 0.1 t dt. So we need to integrate this, and this is going to be an integration by parts. I'm going to let u be equal to t. That tells me du is equal to dt. dv is going to be 0.1 e to the negative 0.1 t. So v is equal to negative e to the negative 0.1 t. So when I integrate this, I have u times v, so negative t e to the negative 0.1 t, taken between 0 and infinity, minus the integral from 0 to infinity of v du. So negative e to the 0.1 t is going to make this positive dt. So negative t e to the negative 0.1 t minus ten e to the negative 0.1 t, all taken between 0 and infinity. And when we do this, we end up with just 10. So the expected value of this particular PDF in this particular random variable is 10.